Assalamu alaikum and welcome back guys with another lecture to engineering geology. I hope you all would be doing fine. Stay home, stay safe. My name is Engineer Abid Ali and today we are going to talk about rocks. The presentation content include what are rocks, their types, about the igneous rock, sedimentary rock and metamorphic rock, and in the end we are going to talk about rock cycle. The basic definition include rock, which is a naturally occurring solid aggregate of one or more minerals or mineralites. What is mineralite? Mineral-like substance with non-crystalline structure. The common rock granite is a combination of quartz, feldspar and biotite minerals. The Earth's outer solid layer, the lithosphere crust, plus the uppermost mantle is made of rock. Geologists define rock as the aggregate or mass composed of one or more, commonly several of minerals. There are few exceptions to this rule. Not all rocks are composed of minerals. For example, we have coal. Engineers define rocks which are hard, durable material that can't be excavated without blasting. The definition is based on its strength and durability. The nature and properties of a rock are determined by minerals in it, particularly those essential minerals which individually make up more than 95% of its volume. The manner in which these minerals are arranged relative to each other, for example, the texture of the rock. Rocks have been used by mankind throughout the history, from the Stone Age, like 3.4 million years ago. Rocks have been used for tools. The minerals and metals we find in rock have been essential to human civilization. At a granular level, rocks are composed of grain minerals. For example, minerals are homogeneous solids from a chemical compound that is arranged in an orderly manner. The aggregate minerals forming the rocks are held together by chemical bond. The types and abundance of mineral in rock are determined by manner in which the rocks was formed. For example, many rocks contain silica, a compound of silicon and oxygen that forms 75% of the earth crust. This material forms crystal with other compounds in the rock. The proportion of silica in rock and mineral is a major factor in determining their name and their properties. Rocks, which are geologically classified according to its characteristics. Number one is mineral, chemical composition, permeability, texture of constituent particles and particle size. These physical properties are the end result of the process that form rocks. Over the course of time, rocks can be transformed from one type into another. That is basically we have the rock cycle. These events produce three general classes of rock. Number one is the igneous rock. Number two, we have the sedimentary rock, and number three, we have metamorphic rock. Now, let's discuss these three types of rocks in details. Number one, we have the rocks classification: igneous rock, which are formed from magma which has originated well below the surface through cooling and solidification. What is solidification? The conversion of liquid to solid. It has ascended towards the surface and has crystallized as solid rock either on the surface or deep within the earth crust at its temperature fell. Igneous rock, inside the earth core there are a lot of molten materials and metals that melt because of the temperature inside. The melted materials put too much pressure on the earth's surface. Sometimes the surface breaks, and due to this the magma comes out. When it comes out, it's called lava. It gets cooled gradually and changes into the basalt rock. Then the rest of the magma that doesn't seep out stays inside the earth, and leftover magma inside changes into the granite, the type of igneous rock you may have seen statues made of granite because it's so strong in nature. So what is an igneous rock? An igneous rock is a rock that is formed from cooling and solidification of magma or lava. Okay, let's add that. They form from cooling and solidification of lava or magma. Now what that means is that when molten rock cools down, essentially turns into a solid. That is when an igneous rock is formed. When you think of lava and magma, you probably picture this molten material in the crater of a volcano, and that's exactly what we are talking about. But when I want you to keep in mind that there is a difference between lava and magma. When it's deep inside the earth, under the surface, we call it magma. Once it erupts onto the surface, we call it lava. Now this material, whether they inside the earth or outside the earth or on the surface, can cool and solidify. Okay, there are two types of igneous rock. Number one, we have the intrusive rock, which is also called plutonic. So that give us two different types of igneous rock. Igneous rocks are classified according to where exactly they did their cooling and solidifying. So we have two types. Let's start with the first type. The first type of igneous rock is called intrusive rocks. That means it formed inside the earth from magma. Now as you can imagine, it's pretty hot inside the earth, so that magma is going to cool very slowly. So magma cools slowly, and when it solidifies, it will allow minerals to form in crystals, but because it happens so slowly, those crystals are able to grow very large. So intrusive rocks are always going to have very large crystals. Let's take a look. This is a piece of granite. What you will notice that it's speckled. All of these speckles are different mineral crystals. The black is biotite mica, the pink we have potassium feldspar, the white we have quartz. But the fact that you can actually see them with the naked eye tells me that they are big enough to have cooled slowly inside the earth, and that is an intrusive rock. If you want to know what I mean by big, any crystal larger than 1 millimeter signifies that the rock is intrusive. But of course we can get really giant crystals like pegmatite, where the crystals might actually be bigger than not a millimeter but an actual centimeter. So we are talking about very large crystals here. Those are called intrusive igneous rock. Okay, but what about the second type? Well, as you might suspect, these are called extrusive igneous rock. Instead of forming deep underground and cooling slowly from magma, these form on the surface, and because they cool really quickly from lava, you are going to get small and no crystals at all. As a result, they may even have air bubbles trapped inside, which is something we call vesicular. So again, extrusive rocks form on the surface very quickly, so you get very small or maybe even no crystals, and they may have air bubbles trapped inside. Let's take a look. This is a rock called basalt, and you will notice you can't really see any crystals at all. If you look with magnifying glass, you will find really tiny ones that are smaller than a millimeter. That's a sign of extrusive rock. What about obsidian? Now this is interesting. It's cooled so quickly in a matter of seconds that no crystals were able to form at all. So you have this kind of glassy appearance. Finally, if it's cooled quickly enough, you might get air bubbles trapped in the lava and become a part of the rock form of these vesicle or vesicular texture. You would look for the air bubbles. Okay, based on silica content, igneous rock can be classified as the ultra basic rock, which contain less than 45% silica. For example, we have the peridotite. The second one, we have the basic rock, which contains silica between 45% and 55%. We have an example like basalt. And the third one, we have the intermediate rock, contain silica between 55% and 65%. The example we have is diorite. Acid rock contain more than 65% of silica, For example, we have granite. According to engineering consideration, fine-grained igneous rock cannot be used as aggregate in Portland cement due to its volume expansion caused by the alkali-silicial reaction. Solution can be like used in low alkali cement. Non-reactive aggregates go with the high alkali cement. Add pozzolans, coal ashes, etc. in the aggregate cement mixture to minimize their reactions. Fine-grained igneous rock, for example basalt, are good for aggregates, as paving aggregates goes with asphalt. Setting of foundation needs to avoid weather rock like dam, bridges, piers, etc. Igneous rocks are good for dimension stones like tombstone, etc. because their resistance to weathering, but one need to avoid fractures. Let's take a look at the reference table on igneous rock. So if we zoom in, these are our 17 igneous rocks shown in bold, and you will notice that it's a whole bunch of characteristics shown on this chart. So let's go through them little bit. We begin with these three top rocks, which are referred to as being extrusive or volcanic, and that simply means that lava erupted on Earth's surface and cooled quickly, forming these rocks. Now, because the lava cooled quickly and mineral crystals within it were not able to grow very large at all, and so what we see are some of these rocks formed from lava have a fine texture with crystals that are less than 1 millimeter in size, like this example of basalt or the sample of rhyolite. Notice that crystals are very small, almost impossible to see. We also have rocks that cool so quickly that the crystals are impossible to see. In fact, they are non-crystalline or glassy rocks like obsidian. Sometimes lava cools quickly enough for a little air bubbles to be trapped inside. These rocks are referred to as being vesicular, like this example of pumice right there. But when magma, which is lava inside the earth, takes a long time to cool because it's so hot inside the earth, well, in that circumstance we have intrusive igneous rocks. Some of these intrusive igneous rock will cool slow enough for the crystals to grow inside the magma deep under the ground and 1 and 10 millimeters inside, like this example of granite. Notice how the crystals are much larger and clearly visible with the naked eye. Sometimes if the magma cools very slowly, and the crystal will grow even large or 110 millimeter inside, like this example of pegmite. Notice those large biotite crystals. Now let's zoom back out and see what else the chart tell us. In the center area shows Earth's color, and the rocks on the left sides are lighter in color, and on the right they are darker. Here's the density. The left side they are less dense, and the right or more dense. And here's the composition. The left side are felts, means they are rich in silicon and aluminium, and the right side are rich in iron and magnesium. Finally, the bottom of the chart shows us mineral position. The way we read this, we simply find the igneous rock we are interested, like say pegmatite, and we look down beneath it to see it commonly contains these mineral: potassium, feldspar, and quartz, pelliclass, biotite, and similarly we could look over here and see that basalt or diabase or gabbro contain other minerals like proxene and olivine, and so that's how we read that chart. Okay. Here, as you can see, as the longer the cooling time, the larger the crystal size. Okay, here's a quick review whatever we discussed about the igneous rock formed from cool and solidified magma or lava. When magma cools slowly inside the earth, we get intrusive igneous rock with large crystals. When the lava cools quickly at once and near the earth's surface, we get extrusive igneous rock with small or no crystals. These may be vesicular, meaning there are trapped gas bubbles. So okay, that will be all for today. If you guys have any questions, any queries, feel free to ask. You can contact me through the email, or you can WhatsApp me, or you can just comment down. Stay home, stay safe, take care of yourself.